Well, hello scrappers, Mike here. Welcome back to my channel, and welcome to part 2 of Easy Gold Recovery from e-waste. And we got here some gold-plated transistors and some gold-plated IC chips. A lot of gold-plated IC chips. They got legs. We got all kinds of gold plating on them. These transistors, they got gold plating on the legs. They've got gold bond wires in them. They got gold plating on the heatsink faces. So we got a lot of gold plating here. Now I know y'all are chomping at the bit to see me process these. But we're going to do these today, and I'll tell you why. I keep getting boards in with more of these sorts of ceramic chips on them. So I want to wait until I've got as many of them set aside as I can before I process them. So in the meantime, I'm going to process these today, and we will do this in the next video in the series, even if I don't have all of my boards depopulated yet. But I should have all the boards I have in now depopulated by then. If I get more, they'll just have to wait. Because you guys are really chomping at the bit to see this. But we're going to do this today. And these are different than the ones we did in the last video, which I'll put a link to in the upper right, where we did a lot of metal can transistors. And those transistors, they were gold-plated on the cans, they were gold-plated on the legs, and they had gold bond wires in them. And we got about a 1% yield out of them, which is not too bad. 1% by weight gold. I'm not sure what we're going to get out of these. Certainly, I think we have less gold plating here than we had with the other stuff. On the other hand, a lot of these are plastic, so they don't weigh as much as the metal can ones. So that may work towards bringing the yield up. We'll see. So the reason I did these separate from the others is because these need to be incinerated. These are plastic. They've got epoxy packages here of various types. And these just need to be incinerated before they can be processed to free up all of the gold inside them. Because if I don't incinerate them and I just treat these like I did the others, we'll only get the gold from the exposed metal. We won't get gold from any of the metal that's underneath the plastic, and we won't get the gold bond wires from inside the plastic. So we've got to incinerate these first. Then we can crush them, and then we can process them similar to what I did last time, and we'll see what our yield is. All right, first thing I need to do is weigh these, and then I need to get them into a crucible and get them incinerated. So let me move things around and we'll get started. Alrighty, let's see what we've got here weight-wise. Let's see here. Yes, Richard, I know I'm weighing the bag. Ooh, 87 grams. We got about 12 more grams than we had of the metal transistors. So we might do okay here. Yield-wise, we'll see. Okay, 87, 88 grams. Subtract a couple for the bag. The bag's not heavy. All right. So what am I going to do next? Well, I'm going to get these into a crucible, a little tiny crucible I've got here, and we will put them in the foundry furnace. We will incinerate them. Get them good and hot. Burn off as much of the plastic as I can. Make sure that the flame is good and oxidizing, and stir this well to make sure that we burn up all of that epoxy plastic in there, and we're just left with metal. That's my goal. So let me fire up the foundry furnace and get that started. Okay, let's get this stuff in the foundry furnace and get it fired up. Keep the heat in here. I'm going to adjust the flame so it's good and oxidizing. So when that stuff heats up, it'll burn more than char. I don't want a lot of charcoal and carbon left in this stuff. I want it to actually burn off until there's nothing but metal and ash in there. So, oxidizing flame. This is going to take a little while. I'll give you a look at anything interesting that happens along the way. Alright, this stuff's getting good and hot in there. And the smoke's burning off in the oxidizing atmosphere in there as it comes off rather than polluting the neighborhood. Really no smoke coming out at all. Excellent. We'll just let this continue to go until it looks like all the plastic's been burned off. I'll give it a good stir with a rod here a couple of times just to make sure stuff on the bottom gets exposed to the oxygen too. Everything burns off. Coming right along down there. Woo, it's hot. I've turned the heat down because I don't want to melt anything. I just want to burn off all that plastic. But I think we're getting there. Might be just about done. Alright, the next step is, got this all incinerated, it's cooled down. It's a little lumpy. So what I'm going to do is I'm going to break up the lumps. So we got lumps of ash in here. And it looks like there was a little bit of ceramic underneath some of that plastic. So I'm just going to break this stuff up best I can with my mortar and pestle. If I had more of it, here's a piece that escaped. If I had more of it, I'd probably run it through one of my ore crushers. But I think probably the mortar and pestle will get this done. What are these white things in here? I guess these were ceramic pedestals that originally held the dies of the transistors, but looks like everything's breaking up pretty good except for these white things, which I don't think the acid's going to have any trouble dissolving the metal out of those. So let me just continue breaking this up a little bit and make sure I get all the escapees. Yeah, that looks pretty good. And dump it in a beaker. And I'll break up some more. You still see the gold on some of it, but a lot of it, the gold has kind of disappeared, covered with a black veneer of soot. Anyway, I will keep breaking this stuff up until I get it all broken up to my satisfaction and in this big beaker over here. And then we will go to the fume hood and we will start treating this stuff with acid to dissolve the base metals. So I'll meet you at the fume hood in a little bit. All right, I've got the ground up material in this beaker. Start by putting some distilled water on it. I put a fair amount on. I don't think I used enough last time, and we wound up with some issues. I put about, 700 milliliters or so on there. Yeah, in that last video where I did the other transistors, the metal ones, we had some issues. But there's a lot more metal there than I think we've got here, but still. I want to have some liquid for the metal salts we're going to create to dissolve in. Alright, so put the heat to it here. And then last time I used poor man's nitric, which I'm tempted to do again, but this time I think I'm going to use actual nitric acid. Some of my precious homemade nitric acid here to dissolve all that metal in there. I have a video on how I made this. And normally I wouldn't use it for just dissolving base metal. I'd probably use poor man's nitric, which is a lot cheaper. But, well, this acid's getting old. It's probably losing strength. So, might as well use it up. I can always make more. Put a generous bit in there, and I can add more later. Oh, and we've already got some bubbling going on. And everything's stone cold. That on there, let it warm up, keep the heat in, and reflux it, get the fume hood going, because we are about to make a lot of fumes. And we'll just let this go and get those metals starting to go into solution. So that should dissolve everything except the gold. If there's any platinum there, it won't dissolve that either. I'm not expecting there to be a lot of platinum, but you never know. But it will dissolve the copper, the steel, if there's any nickel there, if there's any silver there, if there's any palladium there, all that's going to go into solution. The gold will get left behind. So that's my goal with this treatment. We're already starting to get some orange fumes in there. I don't know if it's showing up, but I'm sure that's just the beginning. There's going to be a lot more of that shortly as this warms up. So we're just going to let that cook, probably for the rest of the afternoon, and maybe into tomorrow, to make sure I get as much of that base metal as I can dissolved away. It'll probably take a lot of nitric acid to dissolve all that base metal, but, well, I still got quite a bit here I need to get rid of since it's getting old. Alright, yeah, see the orange fumes? Yeah, it's really starting to cook away in there. Alright, so we're just going to let it go, and I'll give you a look at it from time to time. Alright, check this out. It's been maybe 30 minutes. Wow, look how much orange fumage we're making, and the liquid has turned a deep dark blue color. I'd say we're dissolving some copper there, probably some iron too, and yeah, maybe some little bits of gold skittering around on the surface in the bubbles there. So excellent. This is going great. I'm sure at some point the reaction is going to slow down. I'm going to put some more nitric acid in it, but for now, we are cooking good. So I'm just going to let it go. Well, it's been a couple of hours, and the reaction has really died down. I think it might be about time to put some more nitric acid in there. Be careful, though, because this is hot now. It could take off like a rocket. Or not. Okay. Hard time believing we've digested all that metal in there, but we'll let this continue to cook. It's bubbling pretty hard again. Okay. I'll just let it go. I'll probably let it go the rest of the afternoon into the evening, shut it down overnight, and have a look at it tomorrow. It probably will need to go back on the heat and get a little bit more cooking, I'm thinking. You turn the heat up a little bit, speaking of heat. It's looking a little cold. So I seriously doubt all that base metal is in solution already after only one acid treatment and a couple hours of heat. I think probably there's a lot more to go. Alright, I'm just going to let it cook, and we'll check on it again later. Alrighty, it's the next morning. I just let this stuff sit overnight. It didn't look like there was any kind of reaction going on towards the end of the day. I mean, I was pretty heavy-handed with the nitric acid I put in here. Even though it's probably lost a lot of strength since I made it, still a lot of nitric acid went in here. So it's very possible the reaction went to completion, although I doubt it. I don't know. I got a sneaking suspicion there's still some base metals hiding in there. But I think what I'm going to do is I want to pour this liquid off and see what's in the bottom of it. It's too opaque to see. But first, I want to test this liquid for the presence of silver. So let's do that. Get some tap water in this beaker. Put a little tiny splash of muriatic acid in here. See if I can manage a little tiny splash. There we go. So let's put a little bit of the clear stuff from up near the surface here in here and see what happens. We got a little bit of cloudiness in the liquid. Not a lot, just a little bit. So I would say there's maybe just a trace of silver there. Not very much. Probably just a trace. Okay. Unless there's more silver in here to dissolve, which is possible. Let's gently pour this liquid off and see what's left in the bottom of the beaker here. Well, a whole lot of black stuff. I don't see any obvious gold, but I know it's there. It's hiding amongst the black stuff. Let me give you a close-up look at this. So that's what I'm seeing in the bottom of the beaker here. There's a whole lot of black stuff. The white pucks. There's some differently colored ceramic pucks over there. But I don't see any obvious gold, unlike the last batch of transistors where there was a lot of obvious gold there. This time I'm not seeing it. Huh. But it's got to be hiding in there somewhere. So let's see if we can find it. Now, I think I'm going to give this stuff a rinse with some distilled water. Get some more of this blue, copper, iron, salts out of here. Oh, I might see some gold. Oh, yeah, I think I see it in spots. Yeah, there's some gold in there. I see it now. Okay, it's just there's so much this black debris in there, which I think is broken up ceramic. Yeah, I see gold in spots. Okay, good. So I knew the gold was there. I just was having trouble seeing it. Okay, let me wash down the side of the beaker here with some distilled water. Get everything at the bottom. We'll get this back in the fume hood. We'll hit this with some Aqua Regia and see if we can get that gold into solution. Like I said, I wouldn't be surprised if there's still some base metals hiding in there. So we might make some nice green Aqua Regia as per usual, but we'll see. Maybe we'll get lucky. It'll be nice and clean. All right, time to get some Aqua Regia on this stuff. You know, all these ceramic pucks in here. Okay, that explains why these transistors were so heavy compared to the metal casement. You know, I thought it was epoxy all the way through, but a lot of them have those ceramic pucks inside, and the epoxy must have just been, like, they must have just been dipped in epoxy at the end of production. Anyway, we're going to put some uriatic acid on here. Not a huge amount, maybe a couple hundred milliliters. And here we go with some nitric acid. That's about 2.5 milliliters. I'm going to put a bit more in. I know there's not a lot of gold in there, but there might be some base metals in there. And I know they're going to react with the nitric before the gold does, so we're going to put a little extra nitric acid in there just to be certain that we get the gold into solution. Put a little heat to it, cover it up, and wait and see what happens here. A little bit of a stir, and see if we get that gold into solution. Alright, while we're waiting for the Aqua Regia to do its thing, let's see if there's anything else of value in this liquid. Like maybe palladium. We've already determined that there's at most just a tiny trace of silver in it. I don't know, that cloudiness may just be from the turbidity of the liquid, not actual silver. But certainly not a lot of silver there, if there is any. Let's see what else we got. You know what? There could be a slight trace of palladium there. But again, I think it's just a trace. I don't know if the orange-green color is coming through. Sort of orange in the middle, green around the outside. I think we might have a little bit of palladium there, but again, just a little bit. So, well, I don't want to put this in my stock pot because it's got silver in it. And I try to get the silver, the gold, and the palladium segregated from each other. What I might do is put a little bit of muriatic acid in here. That'll cause any silver in there to precipitate out as silver chloride. And then I could filter this liquid and put it in my temporary stock pot and maybe get a little bit of palladium out of it in the future. I think that's what I will do. So I will do that off camera and clean up a little bit here on the bench, and we'll go back and we'll take a look at what's going on with the Aqua Regia. And what's going on with the Aqua Regia is not much, really. I'm a little bit surprised I'm not seeing a more vigorous reaction. There is a little bit of bubbling, so there is something going on. But really, this is a very lackluster reaction. But maybe when it warms up a little more, we'll see some more action. I'd like to see the gold going into solution with a bit more vigor than that. Well, oh well. Just let it go and see what happens. I'll go back and clean it up the bench. Alright, this just had a few more minutes to warm up, and okay, we're starting to finally get a more vigorous reaction going on in there. That's what I want to see. Yeah, I think we're starting to see traces of orange-brown fumes in the beaker too, so I think, yeah, the gold is going into solution. Nice. Let me give it another little stir here. Yeah, okay. Huh. That seemed to have killed the reaction. I'm sure it will come back. Yeah, there it goes. Okay. So we'll just let this cook until I don't see any more reaction in there. Alright, now we're cooking good. I guess the reaction just took a little while to get started. But yeah, we're getting a lot of foaming in there. We're getting some fuming, the brown-orange fumes. So that's nice. Okay. I'm just going to let this go until the reaction is done. And then we'll give it a test with some stannous chloride solution and see how it looks. See if we've got the gold in solution. The gold's going to be the last to go. If there's base metals in there, it'll go in first. So could very well be that this reaction could go to completion and we'll find there won't be any gold in there because there's still base metals left in there, and all the gold just comes right back out of solution on them. So we'll test it and see what we got, and if there's no gold or the indication is really weak, we'll put a little bit more nitric on it and cook it some more. I got a feeling though that this is going to do the trick. I put a lot of nitric acid in there. Okay, the reaction seems to be dying down. Let's do a quick stannous chloride test on this stuff and see if we've got any gold in solution here. Get a little bit of it, get it on the spot plate itself, and we'll take it over to the bench and we'll check it out. Okay, let's give this a little bit of a test with some very fresh stannous chloride. Oh yeah, okay, it went purple, then it went black. That tells me we got some gold there. Okay, good. I'll get ready to denox this stuff because I'm sure it's probably got a little bit too much nitric acid in it. I was a little heavy-handed with it. And then we will filter it and drop the gold. Alrighty, the reaction seems to be done. I've got the heat turned off, but it's still hot. I want to try denoxing this stuff. I bet there's an excess of nitric in there. I wouldn't be surprised. I've got my usual saturated solution of sulfamic acid here. Let's see what happens. Yes, we're getting a reaction. Okay, good. That tells me that there's still nitric acid in there, which means that it wasn't all used up by base metals and gold going into solution. So, since there doesn't seem to be any more reaction going on in there and there's still nitric acid left, I would assume everything is in solution. If the reaction stops and there's no nitric acid left, then I have to wonder if all the metal's actually in solution. Alright, let me get some ice on this stuff. And we will get it cooled down. And then once it's cooled down and the ice melts, we can filter it and then drop out whatever gold it contains. Alrighty, the ice has melted. Let's get this stuff filtered so we can drop this gold. This should go pretty quickly. So let's get this filtered. And as per usual, I will get the liquid through before I pour the solids into the funnel up here. Because once the solids go in, the filter is going to clog up, and the last bit of filtration will go really, really slowly. And it's not as green as I was afraid it would be. It's mostly yellow, coming through very clear. That's good. Excellent. See how much gold there is in this stuff. Very shortly, we will find out. Okay, I'm going to finish the filtration and get this back in the fume hood over here, and we will drop the gold. Before we drop the gold, I thought I'd give you a quick close-up look at what's left in the top of the funnel here. I've rinsed the color out of it, so I think we've got it all down here in the beaker, and well, it's greener than I thought it was at first, but that's okay. We'll still get some gold out of it. Yeah, a lot of those epoxy dipped transistors obviously were built on a ceramic puck and then just dipped in epoxy at the end to seal them. But hopefully we got all the gold out of this stuff. There's none hiding inside ceramic anywhere. All those holes in the ceramic where the legs went through seem to be empty. So I'm hoping we got it all. Alright, let's get to dropping the gold. Alright, I guess we're ready to drop the gold, however much this stuff has. We're going to use Stump Out by Bonide, which contains sodium metabisulfite. Make sure you get the stump out. Other stump removers don't contain sodium metabisulfite. They contain other stuff. So you need this stuff. Now I do see some other YouTube refiners seem to be switching to using iron sulfate, which does have its appeal, I have to say. Certainly, it's going to make a lot less stinky sulfur dioxide gas than the SFE does. I think it's just a little harder to clean up the gold afterwards. So far, there's not much happening there. Just put in one more spoonful. Cover it up, keep the sulfur dioxide in, and we'll see what happens. My SFE is old and lumpy too. Maybe it's just time for a new bottle. That's a possibility. Gonna let it sit. It does seem to be changing color a little bit. Yeah, it's darkening up. Yep. It was so green that I don't think we saw it go pale. It lost its yellow color, but we didn't really see that because there was so much green contamination in it. But it's darkening up, and I think we got a gold drop in progress. So good. We'll just let this sit and see what we get on the bottom of the beaker. Well, will you look at that? Nice little layer of gold down there. A little bit of it floating on the surface. It's not all rainbows and puppy dogs, though. This gold took a very long time to settle. It's actually the next day. This is, I would say, borderline colloidal gold. It's very fine. Took a long time to settle out of the liquid. In my experience, what causes that is various metallic contaminants in here, and we can see from the color we got some metallic contaminants. In particular, tin, I think, is the worst offender. Tin and gold, they just don't get along. It's the same process that causes the stannous chloride test to work. Stannous chloride causes gold to come out of solution as a colloid, and that's what makes that test work. And some, I think, tin contamination in here. Some of those transistors did have tinned legs, so that's probably what's going on here. I don't know if I'm going to be able to clean this stuff up as is or not, or if I'm going to have to redissolve it in some Aqua Regia and reprecipitate it. We'll see. But as usual, I'm going to siphon off the bulk of the liquid, and we'll see what we're left with. See if it will actually clean up or not. So let me get set up to siphon. Yeah, that's not too bad. It looks like it's trying to consolidate, even though it took forever to settle out. That looks pretty good. Let's give it a couple of boils and see how it looks when we boil it. Alright, got the gold back in the fume hood, got some distilled water on it, gonna bring it up to a boil and let it boil for a while, see if the gold stays consolidated. It looks like it's trying to consolidate nicely. I'm a little bit surprised. I will decant off that rinsed water through a filter and capture any fine gold that comes over. And I'll give it 2 more boils, same way. It'll dry it out, and we'll weigh it and see just how much gold we've got here. Oh, you look at that. The gold is all hanging out down in the bottom of the beaker. Not in the water column. That's about the best possible scenario. Okay, let me pull this off and drain it and put some fresh water on it and get it boiling again. Okay, we're starting our second boil, and I'm counting myself lucky with this stuff. I can't really believe how good this gold looks considering the muck I've precipitated it out of. There have been times when I precipitated gold and it took a long time to settle that I could not clean it up this easy. The gold would just stay in the liquid and wouldn't settle out again. So I'm definitely feeling lucky here. Maybe I should go buy some lottery tickets. Although, you know, there's not enough gold there to buy too many of them, unfortunately. But I processed as many transistors as I had. Anyway, this will be the second boil. I'll give it 1 more, dry it out, and we'll weigh it. All right, 3 boils done. Gonna dry it out, and we'll weigh it. See how much gold we got out of those transistors. Okay, the gold is finally dry, and boy, it sure don't look like much when it's dry, does it? I don't think there's as much there as I thought there was. Hopefully enough to weigh. I think so. Get this done before the weather comes in. We just got put under a severe thunderstorm warning, and I see it coming at me from the south pretty darn quick. So, and the water's hardly gone down from the last time we flooded. This is getting to be the rainy season from hell. All right, so let's see what we've got here real quick, so I can sort of batten down the hatches and get in the house before it starts here. There's some really fine stuff stuck on the inside of the beaker, but probably not enough to really move the scale. Oh yeah, there's a whole lot less gold here than we had with the gold-plated metal can transistors. Still, I'm sure the yield's pretty good. I can't calculate it in my head, but I'll put it in a caption here. I mean, certainly, if we were talking about gold ore, we'd be hard-pressed to find anything this rich out in the wild. So, e-waste is quite lucrative. So speaking of e-waste, I guess the next video in this series, we've got something else to process that hopefully will produce more gold than that. Okay, let's take a look at it. Well, that's it for all the gold-plated transistors I have. I guess we're just down to this little stuff right here. So I guess we need to get started on this in the next video in this series. So subscribe to see that video and all the other videos I've got coming out on other things. I think you'll find them interesting. And check out my 2 other channels, Electric Geek 64, Mike's Lapidarian Fossils. You might find something interesting on those 2 channels too. And I'll see you in the next video. Thanks a lot for watching this one. Bye.